Okay, we're going to start. Let's start by thanking some of the people of school that actually made this possible. Marcus Cruz, Bob Shield, Tom Moll, Michelle Lutkins that have been working on the website and making sure that the equipment is ready for us to present today. Also the people from Unit 20 that are running a bar in the back. They're trying to collect a little bit of money for the unit trip. So after the event, you can actually, or during the event, you can actually buy beers or wine to just like have a good conversation. I'm Jose. I teach here in the GAD. I have unit number 7, and I'm going to give a little introduction of what the NEXUS is. We came up with this idea of how, out of necessity really, because lots of students were kind of coming to the Bartlett or different schools, coming out of education and realizing that there's very little work out there, and that we needed to start kind of just networking and in a way start kind of building new outcomes and new kind of techniques that we could actually put out there in the market. In a way capitalize on all the kind of accumulated skills that it's being carried out by young generations and not just like end up on work for someone else. The phone call started happening, like the invitations started going for some of the people that are here. We have Paul Nichols and Gennaro Senatore, Ezio from New York as well, connected in Skype. In a way, it became very easy to organize a small event, and we're hoping that we will be able to do it every month, or every other month to start with, where we could actually meet and share a little bit what we're doing, and at the same time, try to maybe organize all sorts of instances of how we could do collaborations, or potentially startups or things like that. Start thinking of what would be the business or the work that we could do as architects or designers, not only just working for an office. So this is a little bit the background of the project. And again, thank you for everybody that is here. We're going to start with Ezio, just to make sure that the technical issues that could happen by doing a Skype conference are not there. And then we're going to jump into my presentation, then Gennaro's, and then Paul. And hopefully, if you guys feel like just joining the conversation afterwards, it should be a very informal mood where you could actually put your ideas out there and not only just ask questions as a kind of a lecture format, but more like develop the ideas that would actually, we would kind of start presenting here. We will go back to the title of the event, which is Beyond Imagination, back when we go to kind of the session of discussion and more conversation. So for now, that's going to be it. I'm going to pass it to Ezio, but he's going to start.
Can you see me? Okay. Cool. So good. Anyway, thanks. And honestly, I haven't been so much part of the conversation of what you guys are trying to do there. Like a short introduction you gave just now. It's that I received the conversation present that paper. But it sounds very exciting, and I'm really glad. Again, I guess I was saying that it's past 3 years, there was on the back that we did a short workshop there for less than a week, 5 days. When Alisa invited me with a bunch of others doing parallel workshops. So I hope there is not much overlap between what is my lecture. How about that? Feedback better? Yeah, basically, all I'm speaking, I cannot hear you, right? So I'm not gonna just turn the voice down. So yeah, only wanted to say there is a lot of overlap between the audience when I lecture here today. Some of the things are not really familiar. A few projects from here, Bartlett, a few projects from my last video with Ezio from last year. Where is relatively the same, but at the same time, I'm really curious about the presentations that the speakers, and it's not so familiar with working involved in the discussion. Now, so I'm going to try to share a screen. Slower. Not my best. Can you see yourself? Yeah, good. Alright. Um, so, see. So this is a quick diagram of larger network around me. I've been working in several places and several offices the last more or less 8 years, but more or less focusing on kind of computational design. Most of my work is focused in academia in terms of production. I'm working at several places, as you can see on your screen, but also start in several autonomous workshops in Greece and Latin America. I'll mention a couple. But then trying to also address what kind of beyond imagination is a bit of a hard issue, but I'll start by saying that my collaborations, one of the things that keeps happening is that I don't so much collaborate with computational designers, but I find myself more and more collaborating with people that from different perspectives. So, for example, I was working for Data Ponzi for a long time, almost 3 years. It all starts from poetry and performance to his work, primarily textual, or even with my one of my current partners, Daniel Woods, who is that also has a background in motion graphics, or even with François Roche, which no, but the latest picture we did last summer in India was trying to establish the parallel production between film, architectural building into small film, making of, and who so students are basically involved by learning, but also involved in the production itself. And then another thing that is more recent, since the year that I was there, is an article I wrote, or let's say more or less, for long, which it's a much larger theme about resilience and resistance that François set up against the term. What my text was trying to do was what's happening roughly the same time when I was in London. I remember having a lot of discussion with Ezio, was trying to talk about code or computation as language. And there is a series of problems with that. Still, I'm struggling with that. But in the essay itself, I tried to test a series of linguistic rules as to how that code. And regardless so much, I guess, of the how much that is futile in many ways, or like how much we assign meaning to words, or how when we find ways of particular assigning meaning to computational physics. What is even more difficult is that when we talk about code in terms of for designers or for actors, then it's not so easy to let's say establish which layer you're talking about. If you're talking about the layer of representation in terms of drawing, you're talking about the abstraction in terms of protocols or code itself. Do you establish meaning on the level of the narrative or the programmatic creation, working on or material? So it's maybe all together, right? So like there's a big constant feedback between all of those layers. And this is another slide that's kind of trying to summarize part of the production of the last 8 years of my work. More or less, I guess this is my vocabulary. The purpose of these categories is on one hand, kind of reflect on the work and categorize it in the way of behaviors and different scales. But so what comes in is that the way that talk or comes with this series of bibliography references, or the way that it's tutorial to students. So all of these courses are still merge into specific categories. The thing that I'm going to from then on is we start from simple algorithms, simple protocols or logics, increase the complexity, go through different projects. To give you guys an idea, I guess, the way that I'm working with production is I started something extremely simple. Like this is plotting specific point through mathematical equations. And this is a very simple project we did with NEXUS Studio several years back. It's a Clifford attractor that we were kind of fascinated with the different form that you could get out of a mathematical equation. And through a series of operations, basically were designed the potential for a desk, I guess, or this desk that was perceived as a, well, I guess, previous slide was showing metal frame with a series of secondary connections and fiberglass in order to get the result, or the whole thing would be 3D printed. But I guess what I want to mention about that project is that the algorithm is super dumb in the sense that it's not aware of its context, it's not aware of its scale. All of the interpretation is happening outside of the algorithm or at the level of the designer in order to articulate what this would be. And another student project that is working on basically exactly the same algorithm. You guys can see the video. But at least in this case, we can place the particular scale and work the same for the strange attractor constrained to the scale of the body, and also made the clouds aware of the virtual body and allowed to be repelled from the message itself to work on the scale of the rest. And here's another drawing of the same project where the students were starting to articulate what could be a 3D printed fabric and a couple of observable results. The next project is from a workshop, hosting weeks, for a couple of weeks, where it basically it's happening here. Points are moving as not aware so much of each other, but aware of global attractors that constrain the movement through centrifugal force and gravity. This algorithm was developed for a scale of a temporary pavilion, and I'm sure you'll see again like couple of the different results and quick rendering of the scale. I think it's pretty relevant to the person is out of scale. As I said in the previous instance, the behavior of the points was not so much related to each other's position state. This picture came at an animation where the points are not only constrained with their trajectories, but they're also flowing in the sense that they're producing specific behaviors through each other. And moving on, this is very similar, but in a different scale. This is a Bartlett and a short version where the students basically allowing for these edges to move around on a mesh that had already embedded information that was trying to be as structural enough as a tensile structure, and further articulated with this series of trajectories. Somewhat more recent, the project here is from the student I did in Japan last semester. Students said this material experiment is did as a basically extruding plastic vortex inside water. Students were interested in developing a much larger project in a semester long. Students were interested in developing an underwater science station that would be studying basically the amount of plastic that's in the ocean itself. Also, using the same plastic or collected plastic and re-including it as a material production to create the science station itself. So we're studying the material framing is in the these are further picture to explain expert not only studying the extrusion of the plastic, but the calcification that is happening in an underwater scenario. And this is a simulation they developed semester as a series of plastic extruders that not only are influenced by the environment, but they also influence the environment as well. So in some ones are moving in space, they're changing the vortex that we have. In the next slide, you'll see the filmed hands. Those are kind of zooming in into the circle of valves that were embedded into this net. And closer up and rendering with how it could be water scenario. So how it's hard to see is kind of with the audience. This is going back years when I was working with Bartlett into the development of the prototype, especially on the computer. There were two algorithms, and I'm going to start with one algorithms on this. One is scalar automata, and you can find that you can get out of local interactions of cells. And I'm going to move on. I'm not really sure where I left you guys. I'm probably going to skip a couple of things, but did you guys use everything?
Yeah, CA was the last slide.
CA was the last slide. Okay, good. Let me share my screen again. It's okay. Frozen? Is that what's going on? Okay. I cannot kill the video. You can kill it. Okay. Share screen. It's good. Let me just. I kind of skipped a few points because it's taking too long. Back in the same context of the Cannes studio, we were interested in testing stream sites and finding a way to combine the algorithms with the site location, with site dynamic. This is a project where it was positioned in the Arctic, and the students were interested in developing an ice hotel, usually made out of ice, so they were looking into cellular automata means for simulation of erosion, but also regeneration, basically finding ways to combine this area with, let's see, it's actually play. through CA articulating structural property, but also erosion. And you'll see some of the earlier experiments we did. Extremely computational heavy, but also not necessarily, how should I say, it's on the edge of talking about simulation, because clearly CA don't exactly have the same behavior, but they use it as a design tool to articulate some of those properties. Okay. Some plans of the final results. Okay. Section. And a quick the axe production is a series of components again. How the extent point would be. Going back quite a few years, and I don't know if you guys saw that slide a few moments ago about maybe interference algorithms. This is an operation with difference in Europe. Forward a little bit. We were invited to create a video as a tool for venture capitalists to basically sell or invite investors into the reprogramming of the core building and styling in Wall Street in New York to a hotel. Here is an animation of the lobby, and like the main staircase connection is the program as a window, the bar, and a little bit of the animation you'll see also like on the streets. So it's a very ironic project. This happened, I don't know, like around 2 months before the Lehman Brothers collapse. So, as Europe was completely outlined with the whole project that I learned. Yeah, he was like, we move on. So, like, even though the main algorithm that described just a moment ago was working to wave interference, the initial kind of design of the organization of the packet itself was on it as a material. So like cutting through material density, and developed basically the same algorithm for two different instantiations of the same algorithm. One was on the floor, a series of cuts, black, with the different programs, the ground floor and the basement, and on the ceiling, wide kind of sun here that is parametrically control how long these X-class suits would be. And here's a quick rendering of the hotel suite itself. Another element that was the attraction and repulsion was articulating these components in the ceiling and the book themselves. Taking this kind of one step further, and these are more student projects, they're basically taking the wave interface and making it dimensional as to start to investigate the abilities that you get in spatial organization, and that's the pattern. Let's see. This is from the portion in the Bartlett. The students basically carving out from the volume through intensities of waves and frequencies, and my computer is running a little bit slow, or I hope it's slow here. And this is now a combination again from the PEN studio where we're looking at the extreme sides. This is a site in Iceland where the ground itself is literally boiling. And they were trying to find ways of capturing the quality of the boiling ground and allowing the building to the design of the building to have similar material. You'll see a couple of animations that basically point out interacting with waves, so you can start to see wave effects, but also secondary interactions that will articulate this answer. Okay. Let's see one more. It was further complicated with this slide. Hold on. Here we go. Calculate the different results of the interference patterns, and the idea here was to visually use the graph itself. Let's see. So okay, literally use the graph itself. I think you can see on the center of this board an idea of a particular tonic. Let's use metal structure with secondary connections, and then using the ground itself as a constant rebuilding of the thing itself. And this is a bit protected in terms of period. So they then were trying to combine specific frequencies and amplitudes with the temperature of the ground itself, and that was where they kind of combined with programs that exist in these areas. So that overall compound, or there were areas that were just out or sculpture elements, and then areas that were more enclosed and using the less arts and components. Nice. Project from one of my centers in Guatemala at Columbia University. Students students the propagation of forces through space. So it's like unlike how structural optimization is. But of course, the students in this case are also interested in the structural optimization itself, but trying to find different ways of making it productive in terms of character of the object itself or field. So although the final object is defined as the ultimate, and the structure is finding particular way to navigate it. And last, I'm just gonna skim through that. There's something before. This is a project from my practice in Greece. We were invited to design the house with some elements and thickness. This was the main concept that we used in order to articulate the 3 units, but also the landscape itself. This is known kind of subdivision rules that can happen recursively and get an asymptotic plane. This is more of the kind of relationships that exist within clouds themselves as you go through the elements scales. But first thing, of course, we realized that we not just keep everything the same scale, but kind of different scales in order to articulate the paths of certification, but also areas where the houses would be. And then try to invert the output in the sense of finding what are all the possible combinations of like neighborhood conditions on different islands, and allow for this thing to be basically commensurate as a 3D tiles, but we're then allowed to aggregate or random aggregations, but then later on impose a series of external constraints that's like following this code. So plan for the enough groupings of stacks to exist together in order to articulate a larger volume instead of an explicit volume for the house themselves. Another component of that, like a major component into this project, was to allow for each unit of these applications to become unique. And we were interested into the texture of the island itself and have like these lines are negotiating between different forces, between the landscape itself and also the property. And what we did was basically use a series of projections from the tower itself to surfaces, and then we projected up onto the units themselves. So as to produce as just like a visual fingerprint for every one of these units because of the placement in the lab. This was a quick sketch report, but this was an idea of how to start thinking terms for further application of interior houses from that. So I would do it. This was a video for an exhibition with this program where you see the simulation of or stochastic aggregation to the landscape. Feedback. Okay, so taking way too long to plan. And let's move on.
That's it.
Yes, thank you.
Thank you.
Do you think I'd be able to see the pictures?
Okay, thank you everybody. First of all, okay, first of all, thanks to
Once again, thanks everybody for coming today. Special thanks to Costa and everybody who was part of the initiatives. I think very good initiative, and it's about time that it started. So I'll start slowly. First, my name is Mike. I'm Dutch. It's a bit complicated here. I finished my studies at Bartlett in the last session, last year, basically this year. And in the meantime, and even before, my interest was sort of widespread from not necessarily limited only to architecture, but I was always intrigued by like the title of today's lecture, Beyond Imagination, either very small things and very large ones. And also the way how I think about space is always zooming in and zooming out and transferring between these fields of perception and also different ways of how it relates back and forth to the ways how we can design those and link them together. In addition to that, I founded a practice and a research lab, let's say. It's called LinkedScale. With that, it's sort of an open platform for collaboration with other designers, scientists primarily, and also from my own research. That's sort of from that. So let's start. I'm gonna start with something that Ezio basically finished. It's sort of this. I think it's Bolivian favela. That sort of, for me, is a perfect example of direct computation implementation, materialization, and something that I'm sort of fond of. Of course, complete lack of top-down approach, but a very strong promotion of the context and so on, and how you sense that, and also, in a way, it's an open source architecture that grabs what it can find and puts it where it sort of fits and where it doesn't collapse. So let's move on. This would be another example that is also has, I think, great significance to me, because it tells us that this structural integrity and stuff that we're always striving for is simply not enough if we take it distinctly. This is a house that was swept after 2011 tsunami in Japan, and it is now floating somewhere, or at least was floating when Navy ships found it in the middle of the Pacific. There will be a project that I will go through later on that sort of relates to the same process and what we can harness from these sort of scenarios. Let's move on. Yeah, this is the path. That would be the other part that I'm interested in the super small. Why super small? Simply because it's intriguing. It enables us so many things. It can be used to sort of it enhances this, I would say, cross-scalar perspective that I want to maintain. It enables us to embed materials, performance, and also computation into physical manifestation directly. Let's go on. Yeah, this is sort of a diagram of the brain. Another very interesting aspect for me, and something that I'm working in actively and have been for some time, is the relation of how we actually perceive work and sort of can re-establish perhaps. I think that at the moment we're in a, let's say, transitional phase when we still need a lot of machinery around us that sort of, in a way, helps us but limits us in the same way that it's understandable. It's called progress. So it's going to take some time to sort of get rid of that. Similar to, if you know, the iPhone, that they sort of got rid of the buttons, the little buttons that were sort of something so normal, and then you just have a screen that sort of enables you to interact freely and more adaptively. So what I'm looking at is systems to directly translate, I wouldn't say thoughts, because it would seem a bit science fiction, but brainwaves and sort of direct connections that are established in the brain as a, I wouldn't say way to, I mean, as a way to design, as a way to directly, unpollutably, by no interface in terms of computers and stuff like that, but the direct transition from the brain to what might come out. Because sometimes I think that languages that we're developing to sort of either code or process information, they can be fantastic, but the spectrum that they sort of cover and can cover is, in a way, very broad. But in certain things, we're so much quicker in the biological sense if we go to that spectrum. So let's move on. Yeah, another sort of project that intrigued me and sort of brings all these aspects together is something that I've been working intensely for the last year and a half. It's actually certain aspects are coming to a next phase right now. Is this enormous cloud of this plastic matter that is floating around. Size is about the size of Europe. It's horrible and wonderful at the same time. So the thing was, the challenge was, first of all, because the scale is so immense that it's impossible to even imagine or image or harvest it in any of the, let's say, established practical approaches. So I had to establish a new sort of work routine how to tackle that. First of all, there was sort of the idea how to locate it and how to track it, because the currents, as we know, are changing all the time and we need to sort of follow it. So I had to do something that can be called ecological computation. It's sort of, I try to link my material parts that I introduced so that they behave in combination with warm and cold currents and sort of track this motion and enable me to connect my structures to these clouds of matter that are flying around and sort of without any additional energy, just by harvesting the energy that is present. And this, we have otherwise limitation. So this is another mapping of this high concentration fields. Yeah. So the next sort of challenge was, okay, now we sort of located them, what do we do with it? I decided to sort of establish a system of units that can sort of work in a very rational, logical way and have the ability to first harvest and then remake the matter that they sort of capture. I will go into a bit more details afterwards about how that is done. This is a map of this condensed field, and what I'm trying to achieve by sort of, when I speak about resilience, is that destruction or sort of collapse of the system is vitally important for my designs. It's not a catastrophe, it's not something that we sort of try to prevent, it's vital. It sort of just means that it's reinventing itself, and it doesn't lose any of the characteristics because of it. It just gains new ones. Yeah, this would be a next stage from the previous sort of blank. We're trying to form the, let's say, the first 3D space. Many people would ask, is this a building? No, I think it's not a building, but it possesses qualities that could become architectural aspects, and that's what I'm striving for. I'm not designing buildings at the moment, but sort of methods that could enable us to rethink how we construct things a lot smarter than we actually do it now. Yeah. So this would be one of these. I have to emphasize, I try to use the simplest possible, let's say, sense of things that I introduced to the system. So this is a very simple unit that can adjust according to the temperature, expose internal parts, sort of a mesh that captures material and can also close four meshes. At certain points when it expands, it sort of collapses, falls out of the grid, but when the conditions change, it reforms and reconfigures as a new platform. This is one of the prototypes. This one was made of paper. Then we made another one from nitinol memory alloy, which enables us to be very, if possible, I always try to do material tests that sort of, as a synchronization tool, at least for the computational work, that enables me to calibrate my tools, if nothing else. The project. So, when we start to think about the smaller scale, why would we need the smaller scale? One of these ideas came to my mind because also these parts are they're not plastic bottles or stuff like that. It's actually quite microscopic particles. So the other part was to design these surfaces, again made of memory materials. But this time I also looked at the nanoscale, very small scale. And by designing some, let's say, ways that they can adhere the matter, they can actually capture them, then change state, process it, and transform them. Sort of this living capacity, moving organism starts to breathe. At this stage, they're still 2D. They are sort of a blanket of this suspended that capture other very small parts. But at the same time, the idea was nature is very smart. So let's try to multitask. So these things sort of become open water and heavy, let's say, kindergarten for for fusion. For other species, the adhesion system for these plastic beads is selective, so it only adheres plastic, not living matter, so there is no cross-contamination. And this sort of becomes the protective bed. Why would we sort of keep our fish and raise them in captivity in cages when you can sort of boost the power of the seabed? So this was another idea. Of course, this system is based on the conditions that change all the time and adapt from, and also reform, and in this stage it becomes sort of almost like an envelope encasing some. It starts to show certain characteristics that could be defined as something architectural for the ground. Again, the principle of embedding is something that enables us by simply wrinkling and folding to not only gain structure, but also structure can be inhabited, both in very small and very large scale. It sort of expands the potential for that. That sort of led to another series of experiments to develop different materials that follow these principles. And later on, some structures that are closer to normal stuff, but with capabilities that are far exceeding the obvious. The thing is, I'm always striving for the design that is let's say, not flashing the output that it does, but tries to harvest as much as possible in the potential to both expand. This is one of the quite early tests of this called ecologies, or heterogeneous structures, based on just a simple, same very simple unit that just by combinations and different logics can be very simply assembled into structures. And I'm at the moment working with systems that contain hundreds of millions of geometries, not instances. So it's, and the thing is that the challenge is that I sort of set for myself, I should do it on my laptop. So the thing is to sort of develop a technique how to overcome the challenges that developed through these experiments. Of course, these structures can adapt through time and also incorporate all the characteristics that I was talking before. They can merge, they can fall apart. There's some of the. So this would be the final image that I'll show today. I'll try to be, was I okay with time? Hopefully. So this is a more complex, almost you could call it even a tissue or something. Again, I try to minimalize. This is actually two different units, but the sort of diversifications of systems that you can sort of produce just by geometry and local and other rules that you apply, you can achieve amazing richness of, or let's say, potential for further design investigations, but also the formation of this structure. Yeah, thanks.
Sensors, actuators, and most of what you've done in the panel as well, actually. So there's quite a lot out there on the meaning of adaptive structures. What I was interested into was the application, though, like the practical application of this concept into existing building. And if you look at what has been done so far, it is adaptive, but most of the time they just play with things they can adapt up to a certain extent, and we are still very limited by the control of something that can be called truly adaptable. New materials, smart materials as they are called, you can get rid of a lot of complexity in the mechanics. If you use smart materials, it's fine, but Yeah, I mean, if you look at biomedics and all these like incredibly vast branches of science, they have they've come up with schemes like bones, as the usual picture that you see around trees. They are truly adaptable, or even leaves. You know, the fact that the leaves, when there is strong wind, just collapse upon itself. So collapse all of a sudden is not anymore a bad thing. While in engineering is perceived as very bad. You know, like if you collapse, while instead in nature things collapse to resist. So if you want 10 seconds as well as an alternative to structure the carry load in a more intelligent way, if you want, not in the usual passive, massive, like this big, see how many columns we have here, like this, it's pretty intense, the amount of material, the amount of embodied energy that this building contains is like incredibly, probably super dimension with respect to what it should be in reality. So what I came up with is a theory, if you want, is a design methodology to design structures in the form of trusses. And I mean, I started with something I was very familiar with, because I was simple like points and beams, right, and stick and joints. But nonetheless, that contains pretty much the scheme of what and how a structure should be responsive and adaptive, playing with control signaling, machine learning, and the structure itself. So I'm just going to skip through this because otherwise it will take a bit too much time. Just to give an example of what I'm talking about, and obviously without pretending to go through the math, because otherwise it will be a bit crazy. But if you look at the simple truss like this one, subjected to loads, there is a way to basically embed actuators. We came up with the mathematical modeling that you can, whereby you can design and optimize structure of such. And then after you do that, you can basically control pretty much every single node and position of these structures mechanically. And it turns out that you can save an incredible amount of weight if you do this. If you compare a normal optimized structure, which is this one, which is done with a conventional way of optimizing trusses, which is called fully utilized design, and you compare the method with what you can do with an adaptive structure, you see that it's like a massive difference. And it's not just because you can save weight, it's just the fact that you can redirect forces and play with the energy inside the structure, and finally assume control of what's going on. The method, in fact, is called load path redirection, because effectively what we can do is that we can understand the forces inside the structure and play with the actuators, which are these magenta line things, which are pistons that go up and down to redirect the forces inside the structure. And and obviously you can do this in 3D as well. So I mean, if you take a dome designed with Alistair Day dynamic relaxation, it's already a pretty good optimized structure. I mean, you will feel, I mean, what is it you can do on top of this? It turns out that you can save quite a lot of weight if you then apply the methodology. That is just the scheme of the truss, really. So you have three structure superimposing, and then that's the first stage of the optimization, is the location of the section, and that's the second bit where you basically run an algorithm that understands where you need to put the actuators. And in 3D is actually nice. There are some schemes that patterns that start to appear pretty visibly. And I mean, just to clarify, every single thing like the line is an actuator, so it's a piston that goes up and down. And by doing this, you can control the entire structure, and then you have sensors on you have strain gauges on the members that tell you the deformation, right? So you process this data, there's a control algorithm that I wrote, you process this data, and then you feed back to the actuators to control the structure. So then you can deal with earthquakes, wind dynamics, any sort of static and dynamic load. And then again, it turned out to be like a ridiculous amount of saving that you can do if you do that. So that it kind of gives us a very good justification for adding something that moves, really. So that is the is the total mass energy of an optimized passive structure, and that is the sum of embodied and operational, because you need operational energy to pump the actuators. Again, the final scheme anyway renders that as no even worth showing. Yeah, like just pretty slender. Okay, so just to conclude, I mean, I'm not going to go through this, but in order to validate what we're doing, basically trying to build now a prototype. Is this one showing? It's not showing anything at all, actually. Oh, yes. So this is really the first attempt. I mean, it's not doing anything intelligent. I mean, it should be stupid. But it gives an idea. So you see, again, there's no audio at all. There's no sound. Anyway. So you basically see that. It's something that I found in the lab, really. I didn't even like, just like reassemble it, and then I fit some, those are the magenta lines and the actuators, and then you have a lot of cables and control and stuff. And by moving up and down these actuators, you can apply a pretty good deal of information to this thing. And so the one I'm building now, it kind of shows a more intelligent thing, which is basically a structure like this that performs pretty heavily under load, and then with the algorithms that we came up with, how to control it and put it back in position. And that thing is like 4 times lighter than a passive structure optimized. And you show that you can basically save quite a lot and be in total control of what you do. That obviously is like a simple example of what could come up in the future, but if you think of applying this to domes and buildings in general, there's quite a lot that could be done. The papers published are actually online, so I don't know, if you're interested and you want to read about that, then just let me know. The other project I want to talk about is final one actually that I started 3-4 years ago actually in processing, and this is about sketches in fast structural solver, but that gives an intuitive understanding of what structures are about, and they're kind of playful. So hoping it will work on this screen because it does. So that's the first one I came up with. It runs a simple physics engine. If anything shows at all. Yeah. Oh my god. Okay. The resolution. So something happened with the. Yeah. Let's try to play it. Oh my god. Okay. So the concept is this. Really, it's the fact that you can do. Yeah, you can do stuff like this. You can play with structure. So the very purpose was to give people an understanding of forces and what was going on in the structure. And so believe it or not, this is using like pretty much 20 universities in UK now to, from students first and second year of engineering to actually understand what is compression, what is tension. If you're really handy, you I don't know, that's the first one I did. That's actually pretty nice. Cables and bridges, and it runs a pretty simple physics engine actually. It's not really. That's why it's nice, because if you do that, then you can really see why bridges are dangerous. Anyway, you got the point. You got the arches. You got the that's a design we did with Expedition. The Burger King, it's really good. I mean, if you push the Burger King, then So that gives an idea of there was a purpose in the game actually. I was interested in understanding stability. I didn't know myself how to deal with stability because I mean structural mechanics, which is the field I'm mostly involved with, is quite difficult to really get the intuition of what you're dealing with. You know, when you're dealing with forces, stresses, shear, bending moment, you know, it's quite complex stuff, and it's not usually explained in a simple way. Actually, they tend to overcomplicate the way in which structural mechanics is taught. I mean, I was at the AA. I studied at the AA for like a year. And they were trying to explain to architects, you know, like concepts like shear, bending. And I got the eye of those guys. They were completely lost, you know. And I understand why they're lost because first of all, it's not easy, and second of all, it's not explained in an intuitive, visual way. I mean, we as human beings are very good of understanding things visually. That's the London eye. You know, you can do stuff. Like pre-tension cable, if you want to understand, okay, these are pre and this one is there. But anyway, so that was the first I did. And to my disbelief, we had such a big exposure out there that it basically motivates me to do the sort of next version of that, which is like, you know, you got to be more controlled, which is called push me, pull me. All this stuff is online actually, and you can have it for free really. This stuff that I'm sure is not online. So and this that became a full 3D model basically that I wrote. And then again, I mean, what's the purpose of doing all this? Is to give. I mean, if you just want to understand how things behave, you shouldn't really need to be an engineer and set up a model, you know, complicate stuff, and you just have a small, you know, you want to put some load up there, you want to, you know, try to load it, then you apply some gravity, and then, you know, just show what you can do, or you can draw stuff if you want. There's a drawing plane that you can control with the navigator here, and then you can, you know, draw some bar here. Yeah, and then with the concept of pulling it, you can just do this. That runs a full physics engine. This one, this is much more sophisticated than the one running in which we pull it, where the entire tensor is a complete solver, pretty much like you see. I still missing the icons here actually, and you know, the moment. What is the bending moment is the amount of flexion that you have in your structure, and that is pretty much you know, there are quite a lot of things that you can do with that, but it kind of shows you the concept. There are other examples actually that. I was running with the previous version that shows that, I mean, it's not just about beams and constraints and bending moment, but what you can do with this once you I don't have this version ready in the new platform. So this is running the previous version. It's still the same, kind of the same engine, but you know, like then you can start expanding and do cable net. But I can't see anything happening here, so I probably won't be able to show this actually. No, it's not this one. Okay, so that I mean, you can start having surfaces. You know, we did the redesign of the British or the courtyard of the British. Using this, and I can't now reach the legend where I would have had something that would call pre-stress, and all of a sudden you would have seen this stuff becoming an hyperbolic parabola, you know, that kind time shape. You can do, the proposition is just the fact that yes, it is points and beam, but you can do surfaces, meshes, and tectonics as well, just with points and beam, so you don't need to go mad and work with nerves or surfaces all the time. So that's what push me, pull me, and is so you can play with this stuff online. It's on this website. Yeah.
Okay, so my presentation is going to be very different from the last three, but it's quite funny to see how much of a crossover there is kind of conceptually with a lot of the projects I've seen today, but we just represent things in a very, very different way, and we work in a very, very different kind of area. So, Factory 15 is a company that I set up with two of us. We're all from the Bartlett, graduated in 2011. And I don't know how many diploma students there are here. I think are there any diploma students, or is it all the master's program? Are there any diploma students? Apparently not. So anyway, we graduated from our diploma last year, and we immediately set this up from our kind of interest in film and animation and direction and architecture. And a lot of people kind of ask me, do you miss architecture? And I kind of often say, I still consider myself to be very much, an architect, or working definitely, very much within the architectural field. And I think we use architecture as a character in all of our projects equally to any of the kind of actual real characters that we use. And we kind of work in several different areas within kind of film, architecture and animation. We are essentially kind of creative directors, and we do our own projects, but we also work as an agency for RSA, which is Ridley Scott Associates, for branded content, so advertising, essentially. We do our own kind of short projects, one of which I'm going to go into a lot of detail today, called Jonah, and that's something we're doing for Film 4 and Channel 4. Well, not 4, they're essentially funding it. And we kind of approach them with the idea. And then we do a lot of kind of architectural visualization, specialising in kind of like the more filmic side of it. And I'm going to kind of play this as I go. So I'm going to show the showreel first, which kind of give you an overview of the kind of work that we do. And then I'm going to go into detail with the Jonah project, and specifically one shot of the Jonah project, which will hopefully give an idea of kind of the way that we work and the kind of tools that we use and the kind of final outcome that comes out of that. So this is kind of going to be running throughout the whole thing, pretty much. Can we link the sound to this? essentially, Jones is a project that we've approached Film 4 to do last year, and it's based in Zanzibar, in Stone Town. And we ended up getting to film it in June, so we all went down there with a big crew to kind of film it all. But essentially, it started off with an idea of kind of retelling The Old Man in the Sea in a kind of very different way. So it's just, any of you who are familiar with the Hemingway novel will know that it's about a man trying to catch a fish. We've kind of altered the story so much now that we're not infringing on any kind of copyright laws, which was the main aspect of getting it written. But we developed this artwork as a kind of right from the beginning to kind of set the ambition for the project. It was going to be a real film project, it wasn't going to be fully animated like a lot of our previous work, but it was very much looking at the architecture of the town. So the general gist of the project is essentially our main character, who you might recognise from Skins or Black Mirror if you watch that. He essentially gets photographed with the world's biggest fish, and that kind of spurs the town and him to change. He becomes semi-famous, the town kind of changes as a result. It becomes a kind of seedy tourist town essentially, and built up with these kind of several neon signs that are all based on the kind of mythology of him being photographed with the fish and the fish itself. And then it kind of, I'll actually slow this down a little bit, but then it kind of, the town changes over a kind of 50-year time period. We represent that in the film over just a couple of shots in real time. But he essentially becomes quite self-reflective when he's an 80-year-old man. We have two actors playing the main character, one when he's 20-something and one when he's 80-something. And he becomes quite self-reflective. He kind of regrets what he's done to the town, and that's reflected both in the actual town but also in the water. We paid equal attention to the underwater environment of the film as we have the kind of city element of the town in Stone Town itself, where the kind of environment of the fish lives. So kind of the idea is that him and his fish are kind of connected. This made me laugh actually when I saw your presentation with like similar interest in that kind of thing. But essentially, the town changes. He regrets what he's done to his hometown, so he goes out to kill the fish, killing what it represents to the town. And it becomes quite biblical from then on. It becomes a bit like, it's called Jonah, so it's kind of biblical in the sense that, he gets eaten by the fish and it becomes a bit Pinocchio-esque. And it's going to be quite interesting. We're basically, where we are at the moment, we did all this artwork last February. This has been quite a sporadic project over the year. We kind of dipped in and out whenever we could. And then we basically got Jack Thorne, the writer of This Is England, to write a script for us, the kind of screenplay. We had a general idea for storyboard. We got him to write the screenplay, and then in June we kind of got a crew, about 20 of us, out to Zanzibar and basically took over this little tiny fishing town for about 9 days. And there was kind of an above water shoot and then an underwater shoot as well. So we kind of got we got two underwater film experts to kind of help us out with all of that, which was quite an experience in itself. And kind of, you'll see a lot of stuff from the actual shoot. And this is just like a over there. That's what it. I'm a PC user. Not too sure. So this is Stone Town itself. So I kind of want to give you an idea of the project, the nature of the filming. That's Kid Wayne. He's one of the other guys at Factory 15. That's the producer. This has been our kind of hotel that we stayed in for just over a month actually. So this kind of gives you an idea of the flavour of the town and the kind of challenges we had to change it from essentially what it is now to the kind of futuristic visions that we kind of set. And setting that kind of a visual ambition for the project really early on really helped in the way that we kind of filmed it. So it was really useful to kind of have that. We printed it as a kind of booklet that we went to, we showed investors and different people to kind of help us get money for the projects and get the crew out there. But then it also helped us when we were actually on site to look at this document, look at the artwork that we kind of made and the visual identity that we kind of set for the town, and it kind of really helped us direct the project and how we want to take it on set. So this is one of the first scenes when they actually steal the camera from a tourist, and that's kind of how it starts. And then they use that camera, which then accidentally captures the world's biggest fish. It was a pretty manic experience with a lot of attention from the town, as you'd expect in a really small town. Everyone wanted a piece of it, and actually getting people to not look at the camera was immensely difficult in a lot of the shots that were on street level. But luckily we had a lot of runners, a lot of local guys kind of helping us out, and blockading the streets, speaking the local language, and generally, just helping us out. And that was one of the main characters. But it was some fantastic locations, and that's why we kind of emphasise in all of our projects, for those of you who are familiar with our work or not. But the architecture plays like a huge part in kind of all of our projects, and we definitely see it as a kind of character. I'm trying to skip through a bit. This is one of the locations of the jetty. This is where he actually gets spotted with the fish. And although we did all the artwork in the water, we were actually giving all of that post work to another company called Jellyfish, and they're helping us realise all of the underwater aspects, including the fish. So we kind of showed how we want the fish to look, and kind of did some basic renderings, but they're actually taking on the brute, the main workload for that. And the casing, I don't know if it's in this, but the casing for the actual, we use the Alexa, which is the best digital camera in the world at the moment. That was more or less where the 90% of all the budget went, which was kind of fun at the time, but not so much fun when we're now sitting in the studio doing all the post-work with that money. So, but the underwater casing that kind of housed that giant camera was, it looked like Thunderbird 4, it was amazing. It wasn't all as much fun as it kind of seemed. There was a lot of work involved, I promise. I didn't actually put this together. This was one of the offices of the day for John at that point. Skip through a bit more of this. Gives you an idea of some of the environments we were filming. So, this is the shot I want to talk about, and this is one of the more complex shots. This is kind of where, after he's been photographed with the world's biggest fish, there's a kind of huge montage across the town where the town changes from the old stone town to the new stone town. And all the kind of neon signs and all the kind of different things that we've added to the town kind of materialise in real time on top of the architecture that's already there. And this happens over kind of 15 shots or so, but this is the shot I'm going to go into detail so you learn a bit more about the process as we go to create this kind of stuff. And then there's a few more shots at the end that kind of the actual project itself. It's quite nice to actually show some new work because we've been showing the same projects for quite a while now. So this is the raw shot itself, with nothing added obviously, on the Steadicam, and following our two characters as they're kind of walking through Stone Town as it changes. And there was such amount of richness in kind of texture and just the spaces were really nice. We looked at this and had a semi-heart attack with all the kind of wires that were going across and all the roto that work that would have to be done. But we really wanted to kind of get this one in there somewhere in the edit, and it luckily is. So that's the shot. And then we've got the track and the base geo. We do all of our tracking in a software called PF Track. And it's really, really good. And for shots like this one, there's a lot of parallax. It's a more or less automated process. On shots that have a lot less kind of parallax or kind of distance between objects, which obviously change, then you have to do a bit more manual labour on it, and it becomes a bit more of a faff. But for this one, it was relatively simple. We got a solid track after a couple of attempts, and then the kind of base geometry was kind of modelled, and we can use that as a base to kind of add all of our different elements onto. And then you kind of got the animation of the different things that we wanted to put in, and this is kind of like, again, different kind of fish-related kind of things appear from nowhere, all about him and the fish. And this was kind of a rough outline of kind of what we wanted to achieve for this particular shot. And again, we do all of this within 3D Max and then several other plugins to help us do particular particle effects or whatever we want to do. A whole bunch of stuff we use. But then there was the kind of animation of the individual elements themselves, and these were kind of tested on their own, and they were kind of Some of them are kind of rendered on their own just so you can see what they look like and how the materials are working. And then they were kind of composited within the main shot itself. So this guy lives up there. And we use Nuke for all of our kind of compositing work. I'll go into that later in the kind of workflow of that. But all the kind of rendering work we do within Max and V-Ray. But this was kind of animating all these different elements and kind of compositing them within the shot, all separately. So you can kind of see each element kind of build up as it kind of goes. Then you've got kind of the posters which kind of materialise everywhere, and they will have either fish or our main character related elements on them. So you'll see his picture pop up every now and again. And then animation of the individual elements, that was just done within Max's own P-Flow toolbox. And Rayfire and other plugins used in PhysicsX. And then this is again, kind of you see this guy on the right here, kind of materialising. So everything's kind of broken down separately, and then the kind of the bar at the beginning, this kind of fish bar, kind of crumbles in. And you see that here. And a lot of roto work obviously for the characters, but luckily we didn't have to do any of that. So this kind of breaks down every single kind of element within the shot, and it shows you how it's kind of composited within the main shot. And it's an immense amount of work for 15 seconds or less, 10 seconds of footage basically. 10 seconds of the film. And we've got about 20 of these shots to do. Luckily some of the kind of models kind of come into play in numerous shots that are not just used once, and because we invested so much time and effort in the artwork at the beginning, a lot of the assets that were created at the beginning were used throughout the whole thing. You know, you've got these kind of animated signs that were then used, and we joked around with a lot of these, and that was then kind of composited within the main shot, and you'll see them just underneath here. And it's kind of TV, kind of holographic TVs that kind of pop in. And then you kind of got the compositing element of it, and we do all this in Nuke basically. Nuke's a fantastic compositing piece of software, and it kind of really shows you how to, compared to something like After Effects, which is more familiar in the outset, but very, very limited in what you can actually do. And this kind of shows you how some of these elements were kind of combined within the main shot, and the kind of the things that kind of make up each kind of section. So each kind of colored box is essentially another set of renders that came out in this set in a kind of particular area, and it's still kind of layer based top down. So the footage at the top, and then all the different elements are kind of rendered and composited on top. But yeah, it's a fantastic bit of kit. If you're doing anything to do with animation or filming your work, it's definitely worthwhile. So you can kind of see the main kind of tree, the new kind of script tree, as it's called, animating all different things. You've got the animated signs, and all composited into the shot here. Then you've got those little circle guys who are kind of the camera, which is exported from 3D software into the compositing software, so you can kind of line up all of your kind of graphic elements on top of the where you want them to be in the main thing. And then you've got all these kind of flying guys here, and you see what the motions were added there and then composited into the main stack. So everything was kind of modeled, rendered, animated separately, and then kind of composited within this one shot here. You can see the posters here, and they all kind of feed into the main stack. And you have, what's this? Yeah, all sorts of signage. This was kind of all rendered that, and then the kind of cut out, and then the composite on top of the footage there with motion blur. And then we use a lot of kind of 2D plate elements like smoke and fire, and we use all that within the comp. We don't bother rendering any of that unless it's a particular thing that we haven't got an asset for. And you see the smoke elements there. And then you kind of backtrack to the actual bar at the beginning. And you can kind of see that with about how that was all built up. So the render of that on its own. Again, all from the same camera, because the camera file is all separate. And then the composite on top and colour graded. So yeah, and then the final kind of grade on top, you kind of see before and after with all the elements on top, and it's, you know, all comes together. And then this is the final shot from start to finish. It's not playing hugely smoothly on this machine, but you get the idea. There's a little bit of rotor to finish at the end of it. And then there's a whole bunch of other shots we've done. That was kind of the main workflow for that one. We've done lots of shots. I'm going to show you a few now. There's the whole sequence when he's an old man, where the kind of town is all destroyed, there's rubbish everywhere, and no one really cares about the old fishing town anymore. It just becomes about making money, and it's everything is revolved around the town. It's not about the beaches or the fishing. This is probably one of the only fully rendered ones actually with no context at all, and it kind of looks like that. I'm not really happy with this one. Then there's obviously other elements that are animated. This was a particularly fun one to do. Of this kind of cart, which gets composited in the next shot. So the back of this guy's bike was kind of jointly tracked, and then this kind of car rig was kind of attached to the back of it with kind of dynamics, allowing the kind of elements to fly out of it. There's a whole bunch of shots throughout the town in a transforming sequence, where he's kind of all based around him becoming this weird, semi-famous guy in the town. It's quite funny. And time lapses on the beaches to show how they kind of change over time. But we're kind of hoping to release the film. Well, it's going to kind of tour. It's going to do the festival circuit from the new year, starting in Sundance, and then hopefully be on Channel 4 and Film 4 within a few months after that, and then probably a few months after that it will be online, so everyone will be able to see it there. It's quite a slow process when you go through these people like that. This isn't finished. But you get the idea of the intention for it. So yeah, that kind of shows you where this project is at the moment. It gives you an idea of the kind of process that went through to kind of get to this stage. And yeah, I mean, we've got lots of other projects in the pipeline, but this is kind of the main one we're doing at the moment. And hopefully we can all answer some questions. But yeah, thank you very much.
Hello? Okay, so we are kind of running out of time, so we're going to try to keep it short. Obviously, because the main part of the event is about the conversation, we're obviously going to have that. And I'm going to start with a very kind of quick question, but comment as well. Just related to the kind of the title of the event in a way, Beyond Imagination. And I want to give a twist to that, not in the traditional sense in which we would think like the creative process being the shape itself or the form that we're kind of designing, but rather how do you guys in a way find the position that you're in right now as an architect or engineer, and how you navigate in a creative way to find your own kind of position and let's say how to do your own work. Each one of you is kind of very independent. It's actually producing its own work in a very creative and perhaps not so traditional format. So I'm kind of curious how you ended up there, or do you see yourself kind of constantly migrating between this kind of, in a way, very weird landscape of actually productive work? Right? So that's a bit the question that I have.
Okay, first start. Basically, we find ourselves in the place we are because during our 2 years at the Bartlett and doing our kind of postgrad masters in architecture, we we were already operating within film and animation because we were in NEXUS animation unit or film unit or whatever, and we were kind of actively getting our work out there during those 2 years on blogs and different forums, and we kind of developed our own individual kind of reputation online, I guess. And kind of when we then formed Fracture 15 a week before the Bartlett show that year, we had a big party in Brixton, and we invited lots of people to it, basically, including all the TV channels and stuff like that. And then it got featured on BBC News, and then lots of people saw that. And then we got a few of our projects kind of viral online, and then we got signed to RSA and Willis Scott Associates through that. And then from then it was kind of a snowball effect, and we jumped on the chance while everyone thought we were kind of cool, I guess, at the beginning. We got the idea for Jonah together, and then we pitched that to Film 4, who were interested in doing something with us, they didn't know what. So we pitched the idea to them in its infancy. No one knew really what it was at that stage, but we thought this was our opportunity to do something. So yeah, we kind of got that ball moving, but then also, because a lot of us have done a lot of architectural visualization in the past, we got essentially money clients that way. So we do that on the side. That's kind of our commercial product. And then we kind of do our own projects, which are becoming more and more funded, but immediately less so that we do on the side, basically. And then the whole advertising thing is kind of a plus point to that. So yeah, just through that process as we finish with it.
Can you just repeat the question?
Yeah, and it's, how do you find yourself doing the work that you do, basically? In a way, it's diverging a bit from the kind of conventional, in each one of the cases is diverging, and it's very creative the way you kind of find yourself operating in a productive environment and dealing with clients, or in a way your outcomes are related to a very kind of creative approach itself.
I think it's a pretty tough question to answer, actually, because it's like when they ask you who you are, you can really define who you are and what you do. I can't. I mean, I try and I say I've always been very interested in math and geometry and games, right? So basically, if you mix these three things, then you come up with alternatives of looking at things like. So what I really, really enjoy the most is to make something that is incredibly complex to look very simple. And so probably that's how I ended up doing what I do, to transform things that are difficult into, they're still difficult, but they're simple to interact with, and then so you can find yourself with them, and not just trying to, understand. I don't know if you answered the question, but
Yeah, just to remind everybody that it's just still here from the presentation. I know we ran into some technical issues, but he's still here if you want to add to that as well.
Obviously, I have been having some sound issues with my notes. Don't always hear you, but I've heard just stuff. Not so sure that's your question. Honestly, I've been, since the day I graduated, which was like, I guess a few years ago, around 2006, I've been, as soon as I left academia, I jumped back into it. So I've never really, you can hear me, that's right? What's that? Okay, can you hear me now? Maybe? Yeah. Okay, good. No, I guess what I was saying is that primarily my work, my research is developed in parallel to academia. So the university has been an incredible incubator for developing not only the tools but also the discourse. So I don't know. I think as far as I remember myself being an academic, I've never really left the university. Like when I was done, I was just back in. In terms of practice, I find myself less and less kind of establishing one particular identity as professional practice and more working expertise, the more it's also relevant to actually other fields. That's how I try to survive in life.
Yeah, for me, it's actually, the whole thing is a continuation from the very early childhood. I had a wonderful fortune to have a grandfather with sort of experimental mind, and that was sort of the first incubator. And then all the other incubators, including Bartlett, were crucial for sort of upgrading this. And always, apart from the traditional school-based stuff, I was doing stuff on the side with either myself or other people, expanding horizons. And this sort of, that's why I like your title for today. It's crucial to go beyond the
empower you to use very sophisticated algorithms, and then you can embed some logic. So that's how I started, and I keep on doing that nowadays. So doing a very more kind of constrained flow, because you have to deal with money, you have to deal with clients, you have to deal with that stuff. And so it's about playing, and it's about imagining to be something that you can be. In my case, it's accessibility.
For me, probably the biggest sort of, if there is something like that, is definitely sort of playing with comfort zones and uncomfort zones. That sort of gives me the buzz. Constantly staying in the uncomfort zone. It may sound strange, but it's super productive.
Can I add something to that? And I think that even this event was trying to do exactly that. I thought that the idea of just going to that not so comfort zone where, like, as Paul is showing up, like some content that is completely different from, let's say, some of the content that we're kind of used to in some areas of the school, and really kind of trying to merge different ideas and different kind of discourses. I think that this is precisely like the idea that maybe we're stuck, or maybe we're trying to find different ways of just kind of opening doors and figuring out how to kind of navigate that scene, because it seems that I feel like in a way we kind of architects are just a little bit stuck in the sense of just kind of what do we do at the end of our education, right? Like, so that's in a way going back to the idea of this event actually, but also kind of thinking, well, we need to figure out how to break that kind of block and start wiring ourselves in different ways. And as much as it could be a bit uncomfortable or just having to deal with some technical difficulties sometimes, this wiring needs to keep on happening, and I hope that the event could keep on happening in a way that could bring these comfort zones, or like this non-comfort zone, just to be even more radical and more kind of, that's the place we want to go, right? Like,
This is the answer I see also here, about these different disciplinaries coming together. This is for me the answer to you said about open source processing. This is the whole idea. That's why we're here. And I see.
At the same time, you have like all this kind of open source content. There should be a place where you could actually, this kind of copy-paste culture needs to start kind of being, called. I mean, we are the community in a way that is kind of building all sorts of outputs, and we need to just say, well, we have these tools, we have these other tools, and as much as we could be open source, it's all about the amount of effort that these kind of people are kind of putting into their algorithm, right? It's just like you realize that you you might be able to do a few of the things that you've seen on the screen, but it's only that persistence as well, and that kind of passion that these guys are actually putting into the work, that I think that by also wiring is really kind of breaking these kind of blockages.
Well, taking on that part. Well, first of all, congratulations to all of you. I mean, the work you are producing is incredibly amazing, but there is something that really surprises me, and that you don't find quite often, that is people pushing for doing their own things. It's obviously that you guys are doing that, but I want to be so practical with my question. Is what would be your advice to the students? And I'm making these questions because I asked that to myself many times. I've received that questions many times as well. So I work for an office and keep doing. I feel really anxious.
That's also the point that I'm trying to sort of reason for. You have to be rational to sort of say, oh, this gives me disadvantages and this stuff gives me more hours of sleep. I don't know. It has to come from within. It's sort of, it hurts but it's not suffering, something like that.
I'm confused. But I agree with what he said. And I really agree because I think that I never thought about what I was going to do next, right? I just got interested in the thing that I was doing, completely immersed, in something might seem a bit cheesy and, trying to create some poetry about what one's do, but you just don't feel time, right? You just keep on doing that, and if you are lucky and clever, you put some effort, then eventually you come up with something that gets out there and is very rewarding, and if you're lucky enough, I give you some money as well. So that's just to make a point on the open source word. The open source is not cut and paste, and it doesn't have to be. When I talk about open source, I'm not talking about the little snippet of script you can find on the ecosystem blog, which is an amazing source.